Hello everyone, December 14th. Alright, let's do this. I'm super duper full. Just had some great food. Maximum average pass ratio. There is a school that has classes of students, and each class will be having a final exam. You are given two integer array classes, where classes I is pass and total. You know beforehand that in the ith class there are total students, but only pass number of students will pass the exam. You're also given integer extra students. There are another extra student, brilliant student, extra students, brilliant students that are guaranteed to pass the exam of any class they're assigned to. You want to assign each of the extra students to a class in a way that maximizes the average pass ratio across all the class. The pass ratio of a class is equal to the number of students of the class that will pass the exam divided by the total. The average pass ratio is the sum of pass ratios of all the classes divided by the number of the classes. Well, we don't have to divide because the number of classes is static, right? So all you need to do is just to increase the ratio. Return the maximum possible average class ratio after assigning extra students. Oh, I guess you have to add extra. So first example of this, and you assign the students to the first and to the second, right? To the first class, the average pass ratio will be, all assigned to the first. I see. Okay. Average pass ratio. Because you can assign them to anyone. It's just extra students, just extra numbers, right? You want to add. And when you add to a class, you increase the nominator and you increase the denominator at the same time. And when you do that, yeah, you do make it bigger, right? Every time you do it, you make it bigger because you approach. Actually, I'm not quite sure. That's a good question. I mean, we don't know, but you have extra students, and it's guaranteed to pass the exam of any class you're assigned to. And we want to see what can make it increase more. I have some questions in this, like. I have lots of questions. Because at the end, what we do, is if I have a divided by b, and I have a plus, let's say, x divided by b plus x. How do we rationalize these two? How about we say a plus x minus, what's equal to that? Alright, so this is this, ab plus bx minus ab minus ax. So this counter, so we have b minus a times x, b plus x. Right? So this way I already know. And a is smaller or equal to b, right? So we want to, so for each one I have this. Basically, yeah, just like when you add x to a number, you want to know how much extra, this is how much extra you can get out of it. You always make it bigger, right? You always make it bigger. So how much extra you get is by going through this. We can even simplify times x divided by b plus x, right? Yeah, so this is a value. For each number, it's like a coefficient. It's static for everything. This you can further simplify. It's like divide by x, so it will be 1 plus b divided by x, right? So basically, for each number, you can compute this, right? You can compute this, and actually, that doesn't really matter, right? It doesn't really matter. Well, it does matter for a single one. Of course, you add more x, right? So x gets bigger, this one gets smaller, and the total becomes bigger. Like if x gets giant, right? And then this one will close to 1. X go to infinity, this one become 1. And if it's, and then it's 1, yeah. So for each number, yeah, it's guaranteed. You put the maximum in it, you get the best benefit, right? You get the best benefit. Now, the question we have is how do we distribute these extra students, right? How do we distribute? And to distribute, what we need to know is, I have a feeling that the answer is you have to do the extra students to just distribute to one, to a specific one. Because the extra earned, right? You give some, you get extra. You give some, you get extra, right? So for each one you give, you get this extra, right? You get this extra. If we even it out, and then for each one I got this much. But if we just do all I'm not sure this. Maybe you put all 4 of them here, or you put all 4 of them here, right? You simply don't know. Maybe we can prove it, right? Maybe we can prove it. So this is basically for 1, and then I can get another one, right? If I can prove that you get everything to 1 will always be better than give it to both. That's actually a good proof, okay? But anyway, we have this. So this one we will prove is we add more, we get more benefit. Okay, so that's good. So now I want to see, I'm not sure if we can prove it, but all we see is, let's say we have b1 minus a1. How do we say it? So we say and now we have a b2. How do you give it to a b3? That's the question, right? Do we split it up or not? Well, apparently, maybe we can analyze this a little bit more. because we want to get the most bang of the buck, right? So this is b minus a divided by b times x, b plus x, right? And b is in the, and I will say this is 1 plus b divided by x. Apparently, the bigger the b, the bigger x needs to be, right? If b is small, then x can be small, but well, x can still be large, but this one will always be smaller than 1. And this, yeah, I mean, they'll always be smaller than 1. But if there's a big difference between b and a, right? If there's a big difference between b and a, then we'll have a big here, right? We'll have a big here. So the difference between the two is big, right? And so we want the biggest benefit. So we want b minus a. We want to maximize b minus a, right? We want to maximize b minus a and then minimize b. That's what we want. The smallest b that can give you the biggest b minus a will produce the largest of this. I do believe you have to give this to every single one. Actually, we can try in this. Right, so if we say b minus a, then it will be 2, 6, 1, and 8. Okay, and the b value is 4, 9, 5, and then 10. If we go the max, so this is the max, but if we want a minimum b, this is the minimal. So it's really hard to say. Maybe, because, I mean, if you wanted to do that way, you can just go ahead and then plug in every number and just to see, right? We can just say extra students give every single one we go through and then see which one give you the biggest bang of buck, right? Which one give you the biggest bang of buck? That give you the biggest increase, and then you'll choose that. But I don't have a good proof that this is the best strategy, right? This is the best strategy. So basically what you're saying is if you give the extra students to one specific class and it can produce this much, right? It can produce this much extra percentage, extra ratio. And you're saying is, by doing this, it's always better than giving it to another one. Because this is static, right? This is static. So one of them will have the biggest ratio increase among everybody else. And if you split it up, yes, that is the proof, right? That is the proof. Because every single one, when you increase the students, this is the amount of ratio that's going to increase, right? Everyone have that, and it's only dependent on the x, right? It's only dependent on the x. And it is the more x you give, then the more it is. And since that is the case for each one, the more x you give to one, then the bigger this one is. So if you give, right, if you split x up, right, you give some to some, you give some to the other, and then it's the other one of them will actually be better, and it's actually better to give everybody. So basically it's like this, right? We have some ratio delta, I will call it delta, delta 1, right? And then delta 2, right? And we say delta 1 x is always larger than delta 2x, right? You put x into it, it's always going to be bigger, right? And now we say we split x into x1 and x2, okay? Then you give it to, say, delta 1 x1 and plus delta 2 x2. You do that, right? But I can argue, because this is always going to be, so delta 1 x1 plus delta 2, or delta 1 x2 will always be bigger than this. So we should always combine these and put into one delta. That is the solution, right? That is the solution. But now what we need to do is go back to this thing. We will put extra students into this formula, find out all of them, right, for each one, and we get a maximum. Then we add this up and add that, then we get a result. Done. It's a more mathematics stuff, which is not really a bad thing. Makes it very deterministic, right? And we can write something about it. Okay. All right. Double res, okay, and double delta. We might be able to do this. Delta equals 0. Okay. And for auto class of classes. Right, we have two values. One is the, I'm going to say int a equal to class 0. Okay, int b is class 1. Res plus equal to double a divided by b, and delta equal to std maximum delta double a plus x, not x, extra students divided by b plus extra students. Expected class name. Right, and then we'll return res plus delta. Okay, let's make sure that this is correct. Then we can write some explanation. That is absolutely not correct. Because I forgot to divide. Classes.size. That was on me. And it's still not correct. What the heck? Oh, because this is wrong. This is going to be delta. My bad. Okay, we have to do a few more things. Double ratio is double. Sorry, it's too excited, I would say. Alright, and then this will plus equal to ratio, and this is going to be minus ratio, and this is going to be this plus divided by classes size. This will be correct. Trust me, bro. Yep, I think it is. Actually, it is not. The first one is right. The second one is not. What? Holy crap. thought it was correct. No way. Really? Oh, I know. Hold on. I think I know something. Hold on. I think I'm I can't get any of this. Hold on. Okay, that's what I get, is put all four of them in this. But none of them hits this, which means we do split it. Then my initial analysis was wrong. How could this be wrong? So it's not this dependent. Okay, yeah, so it's not this dependent. Yeah, I don't understand. Why would you split up? Wow, it is getting bigger. So 2 by 4 times, which is just this, right? 1 over 2. Next is 6, 9, 9x 5, 8 over 10, 10 by x. So this is 2 over 3. This is 4 over 5. Right? So how do we distribute x to make, we can say how do we distribute to make this sum maximum, right? This is the question. How do we distribute x to make it maximum? Well, we can do 0 on this x. Maybe we shouldn't do it that way, because we can make it 0. Okay, so let's put x back. Now we can add them together. Alright, now we can add them together. Of course, it's gonna be like x0, x1, x3, things like this. I mean, we already got the answer. I think the answer is we put 2 here and 2 here, right? No, that's actually not right. There is a better way. Damn. Maybe 3 here, 1 here. No. Huh? I'm not sure. I got 5.33. I got 5.33. Five point 0.53. I don't even know what's the distribution for this. Man, what is the distribution? I don't know. Oh, this is driving me crazy. What in the world? I'm doing something really, you know, I don't even know what I'm doing, but I would rather try it, right? It will continue to rise. I think this is how they all look like. Right? That's how they all look like. That's not true. That's not what we want. Man, I got royally stuck. The thing is, I still haven't found the distribution that make it work. that is very, very troublesome. Okay, I haven't found the way to actually make it work. We can actually, I don't know. Say 1/5. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, we make a thing. Right, so if you do all by one, you do this. Actually, we can do the total. So the total right now is 1.833. So we're going to do 1.33 plus 0.25 divided by 4. Why is that not right? Yeah, 0.52. That's the answer I have, right? I put all here. So basically, if we do some combinations, we can get a bigger value. Basically, that's what it says. For example, if I do this, well, if I take this, I don't have anything that's bigger, right? Because this is 0.1, nobody is larger than 0.1. If I take this, if it's 2, I can take, yeah, this 2.8. Oh, look at this and this. 2.9. So it's 1.833 plus 0.167, 0.133 divided by 4. Yep. 0.533. Yeah, I think that's probably it. Okay, let's try it. So basically it's the first one. So 4 by 6, 3 by 9, 4 by 5, and 4 by 4, no, 4 by 12. No, that's still not it. That's still not it. Wow, but this is already pretty big. That's 0.3. This, and this. No. So you do 1, this is the most. You do 2, this is the most. So you take this, then you take this, and you have 1 left. If you do 3, this is the most. But we tried it. This, you take 3. I honestly have no idea. I'm gonna try the hint. That's true, because this is, we have plotted, it's like this. So the more you add, so which means you just add to every single one? No. Yep, that is correct. I agree. Okay, so you add the first one to the one will give you the most. So we choose this, right? And when you add a second one, so you add these, you get these increase. But if you add to this, then the second one, then the difference between these two, the difference between these two is 0.067. All right, so the second one you should add this one. The third one now we have 0.133 minus 0.07, right? So the difference between these is 0.06. So the third one add this, you add this one. So the difference between these two, 0.054. So the last one you add to this one, because this one gives you the biggest difference. Right, yeah, so basically you pick this. So eventually you add 2 to this, 1 to this, or 1 to this. So 2 to the first one, 1 to the second one, 0 to the third one, 1 to the fourth one. Hey, I got it. Two, I need to use hints. Fucker. Alright, ooh. It's priority queue. Okay, it's priority queue. So what we need is, okay, we need to first get this equation. So for each one, right? For each one, we need to find out if I add it to it, what's the difference, right? The difference. So basically, what we have, initially we have the priority queue. So we do the add 1 to each one, the difference, we go there, and then we get out the first one with the index, okay? Get out the first one with the index. So we say this one will add this much, right? We'll add this much. Yeah, so we'll say, okay, the first one will add this much. And once we choose that, we will find the next, right? We'll find the next. So the number to add. So basically we're gonna do index, right? Index and number added. Number of students added, right? Number of students added. And based on the number of students added, I can know the difference, right? Yeah. So initially will be 0 students added. So we push this in, and when we compute the order, it's gonna be this. Put it in minus this minus 1. This is the difference. So we get the one with the maximum difference. Right? Maximum difference. And we'll this one will just plus plus. So because this, we say we'll add 1 student to that. And then, because this one pop out, right? And then we will push another one in, and then it gets out. We add, right? And then in, and then we get out. Okay. So, so it's TD priority queue. It's gonna be a pair of int and int. Vector pair okay, so we say auto compare. Nope. std pair A B. So we want to do greater. No, it's not greater. So index. Alright, so when I say pair equal to index and number of students added. Diff A, right? We're going to do a diff A is going to be number of students added. Holy guacamole. Basically, it's classes. So something minus something. Okay, what's the first something? It's classes. A dot first as index plus A dot second divided by, I think the elder, this one doesn't, we don't need this, divided by classes A dot first zero, A dot first 1 plus A dot second. Okay, that's the diff. So basically the same thing. Minus so instead of A dot second, it can be A dot second minus 1. That's what we want, right? So this is a diff B. B we need to do something else. Double this. Okay, so that's the comparison. All right, so it's 1 hour, but I think we have an idea how to solve this, but I'm gonna end it right here. Just need to feed my cat. All right, I'll see you guys tomorrow. Adios.